Hi there, I'm Luc Baudouin. I'm a co-founder of CogSci Apps, founder of CogZest, and an adjunct professor of cognitive science and of education at Simon Fraser University. My disclosures are on the slide. So today I'm going to describe the integrative design-oriented approach to understanding humans as autonomous agents and discuss how this could help us improve human cognitive productivity by way of hypertext. This is a slightly longer version of a keynote presentation I gave last week to the Human 22 Hypertext workshop that was held in Barcelona. And so the approach I'm going to describe builds on and is meant to transcend the limitations of cognitive science, affective sciences, and other approaches to psychology. And I would like to start by addressing the skeptics in the audience, and I'll paraphrase a skeptic who said something with respect to our own software. Software is just software. It can have no basis in cognitive science. Appeal to cognitive science are just marketing fluff. And I mention this today because it's true that we can't simply take for granted the idea that cognitive science can be used as a basis for effectively developing software or treatments for that matter. And the critic in this case was a software developer, and I can understand that software developers might feel threatened by the idea that formal education in cognitive science is required for developing software. But that's not what I'm saying. Software development these days for significant projects are typically, for this kind of project, they need to be teamwork for one thing. So there you go. I would like to as well mention the reflective practitioner as a good example of somebody who's argued that one can't simply take science and apply it to anything really in the real world, for instance, in engineering or architecture or psychotherapy or other professions. So typically some reflective practice is required. Psychologist or an engineer can't just infer from science what they need to do. And I think that for hypertext, a kind of similar principle applies. So now I'm going to invite you to join me for a quick journey from psychology to artificial intelligence and integrative design-oriented cognitive science, which I'm going to define. But fasten your seatbelts and get ready for a ride. We're going to go back in history through my history, but it's of broad relevance, I think. As an undergraduate, I was fortunate to have scholarships to work in a biopsychology lab. We studied incentive motivation, although that's not what not the term that we used at the time. But in any event, we did these experiments in which we would prime the lateral hypothalamus, which is part of the medial forebrain bundle of rats, with electricity, and that would cause them to resume self-stimulation of their brains in the same area, okay, because we had previously trained them to do that. And this was part of a research program that would ultimately disentangle liking from wanting. Anyways, I mention this because it's a good reminder that psychology is not just about the cool, dry information processing that's often, what cognitive science is about. So that's a bit of a reminder of that. And also that there's, neuroscience needs to be taken seriously. So we'll come back to this kind of motivational stuff in a bit. I also then had the opportunity to take a cognitive psychology course, which I really loved. And this on the slide there's a Stroop effects, which you can read about if you're interested. But what really got me interested was the fact that you could experiment on the human mind and get data that had millisecond precision and have very reliable results. So the replication crisis is not as much of an issue down here, and they were interesting results that really told you something about the information processing, the mental processes of over the human brain. And I realized that that neuroscience did not have a sole claim to being a very rigorous discipline in psychology. So was cognitive science. So that was really interesting. I just basically fell in love with that and switched into that, if you will, that kind of mode. But I also took a really mind-blowing course on perception that was given from an AI perspective by a remarkable professor called Claude Lamontagne, who would go on to win teaching awards at the university, provincial, and national levels. And he had done a PhD thesis in AI at the University of Edinburgh in the 1970s. So they were really at the forefront of AI there. And I'll come back to his thesis later because it's rather mind-blowing. And one of the main lessons he taught in that course was that, there's often, let's just say, a psychological, I wouldn't call it vacuum. Sorry, there's one of the main lessons that he taught in this. No, let's try it again. This course was critical of a lot of psychology, including cognitive psychology, for its lack of theoretical depth. Okay, so Professor Lamontagne quoted Pauli, who famously said, "This is to show the world that I can paint like Titan, only that technical details are missing." Okay, so his point was that that often a lot of the technical details were missing in hand-waving style psychological theories. And this essentially leads to the argument that theoretical AI should be the central discipline of cognitive science, essentially of psychology in general from a theoretical perspective. So let's talk a bit about theoretical AI. So theoretical AI is a way of understanding actual and possible minds, and it goes like this. First, if you want to understand a system like vision, a function like hearing or vision or anything really, what you need to do is specify the niche or the environment of the system that you're interested in studying, and then specify the requirements of the system within the environment, and then specify some of the designs that might meet the requirements. Okay, so this is part of the theory. All of this is part of the theory, actually. And then you develop your implementations. So computer implementations, and sometimes it's robotic implementations, though it need not be. And all this is essentially developing theory to not only give an explanation of the phenomenon, but show that your explanation can actually work in the real world. There's nothing like pressing the compile button or giving a compile command and running software to see whether one's ideas can actually work. So this designer stance also actually has multiple loops, and the loops are driven by assessments where you basically say, okay, I've specified the niche. Is this the correct niche? When you go down to the requirements in design, you might realize that you missed something. That, for instance, you're studying motor behavior and you realize, these squirrels or these animals are able to climb onto trees. My system can't do that, so let's build that into the requirements. So you basically have to assess what you're doing at every level, and every level in this process is an opportunity to go back to the previous level, to inform the previous level. So you don't actually have to press the compile button or the run button on your software to realize that there's something missing, and you document that as you go along the way. Okay, now theoretical AI is not merely it's not merely aimed at understanding humans. There's a space of existing biological organisms that are also of interest. So you could do this kind of thing, trying to study flies and ants that can do remarkable things. Squirrels are really quite fascinating. So the space of actual living organisms, but possible living organisms too. And then there is this thing of the space of possible minds. In artificial intelligence, that's where it comes in. It's basically defined. It's more mathematical. There's a space there of organisms or artificial minds or agents that have never actually existed. Okay, so using this approach, which is a lot more well known now than it was when I was doing my PhD thesis in the 1990s. We're always hearing about AI these days, but this puts it in a general context. And what I've done on this slide is I've illustrated, going back to Claude Lamontagne's quote about only the technical details are missing, is that it would be easy for a theory of vision to lack a lot of the details if you don't have to run the simulation. So this is Claude Lamothin's, it's a figure from his thesis, which was published in 1976, or which was defended in 1976 successfully. And I don't need you to look into this in any detail, but it just gives you a flavor of there's a lot going on here. And he specified the design and implemented this this model. And one of the things that was quite interesting in his explanation of visual motion perception was that he managed to predict an entirely new class of illusions, essentially, and explain why you'd have these illusions of visual motion perception. I won't get into the details, but this is essentially the setup. Imagine that there's a spotlight flashing in the background on, not a spotlight, but a strobe light. As if you put your finger underneath these dots and you follow your finger for a while and then you remove your finger, and then your eyes will actually continue to track. It's as if you're tracking these dots which are moving, but the dots are not moving. And yet this simulation, this setup triggers smooth eye pursuit. Normally your eyes move in a saccadic fashion, but in this setup you get smooth eye pursuit. So it's really mind-blowing. And again, one of the things I really liked about this that had a lifelong impact on me was that from this very complex theory, you can get, or at least the implementation is complex, you can get, a very simple, kind of mind-blowing prediction of an illusion. Illusions are a lot of fun. Now, predictably, what happened in psychology is, the psychologists got their hands on this, and they turned it into a bit of a cottage industry of looking at the different parameters of this, running all these different experiments. And Claude was just rolling his eyes saying, look, this is not about running experiments. What we need to do is go back to the theory. Sure, you can run your experiments to try to show that what are the limitations of the theory and to inspire developments in the theory, as opposed to just studying all the different parameters of this thing. Which is not to say that experimentation is not useful. It's just that when you're proceeding from the designer stance, which is essential to understanding the human mind, we claim you need to go back to theory, go back to the drawing board. Okay, we're talking about artificial intelligence here, and I'm going to throw in that you may have heard about, AI in general. Maybe you've heard the expression deep learning, and I want to say that despite current fashions, AI is not merely this what goes by the name of deep learning right now, and it's not necessarily primarily that either. That deep learning is just a certain way of doing artificial intelligence. A lot of us recognize its triumphs, its victories at least, and its importance, while also saying, look, there's often a lot of details missing in theory. So it's quite ironic that this approach is kind of a bit like how we criticize empirical psychology, is kind of lacking in theoretical depth. And but that's a different story. There are other people saying this. I am not alone, but I've been saying it. I first, I published a workshop, a poster in 1991, I think, where I was arguing against about the limitations of connectionisms. Okay, but that's just a bit of a tangent. So let's get to cognitive science. I've used expression cognitive science. If you're not familiar with it, it's important to know that cognitive science is an interdisciplinary computational study of mind. It's by being interdisciplinary, as opposed to just multidisciplinary. So the idea of interdisciplinarity, which is often lost, is that a researcher needs to be well versed in each of the core disciplines. So that means you should be able to think like a psychologist, the research psychologist, a philosopher, a linguist, an anthropologist, a neuroscientist, and an AI researcher. And ideally, you should be able to publish in not necessarily all the disciplines, but in most of the disciplines. But there's something, and I got this diagram out of Wikipedia. It's well known, this hexagon. But I think actually a pentagon might be more appropriate here, because this diagram is a bit misleading, because if you look at it, AI is kind of just tucked away there in the bottom left. Okay, and if we take Lamothin's perspective, with which I agree, we'd say that, look, AI should actually be at the center. Okay, so that's the computational aspect, is saying, look, we need to always be thinking using the designer stance. So thinking about the phenomena using the designer stance, not just the computer. So what does computational mean? You might have noticed on the slides earlier, I referred to David Marr and Poggio, their levels of understanding framework, and I just threw in that the designer stance that I described is a bit more general than that. So if you're interested, you could look up levels of understanding. It's quite a well-known framework, and I just want to point out that the framework that I just described, subsumes that, but it's more expansive than that. And there's papers on that, such as at the AISB 1993 conference. If you look for prospects for general intelligence, for AI as the general science of intelligence, you'll see that. Anyway, so AI then promises, which I haven't mentioned, but I'll tell you now, that one of the promises of doing AI is that, well, it forces you have to kind of go deep into the phenomena in order to build a machine that can replicate the capabilities you're interested in. And there's often a promise that through going deep, you can actually get depth. And I do believe that there's a lot of truth to that, but I put it this way, basically, is that going deep is necessary for having breadth. That's breadth that I was talking about. So you can get you need to go deep in order to have breadth, but depth does not necessarily give you breadth. Now, that's actually quite an important concept for this presentation, because I'm driving towards this integrative design-oriented approach that I'm going to spell out as of the next few slides. And one of the core ideas basically is that using this approach, we actually do try to get some breadth of understanding the multiple functions of the human mind. So let's look at what that means. So cognitive science, if you go to the Wikipedia page, you get the impression that cognitive science studies all of natural information processing. Usually it's humans, but it's supposed to be for all human information processing. Okay. But there's another caveat emptor that applies here, because in fact, the all aspect is there's a bit of lip service that's being paid to that. Okay. Now the reason is, and it's not meant to. By the way, I'm not criticizing individual people here. I'm just trying to, throughout this talk, I'm showing limitations of certain approaches. Sometimes they're necessary. But I'm talking about how can we transcend them, right? So like other scientists, say a cognitive psychologist a typical cognitive psychologist will need to study. So you look at something in a lot of depth. So when you go into a lot of depth into something like, color vision, right? That doesn't, like, there's other aspects of vision, there's other modalities, there's other functions in the human mind besides perception, like memory, motricity, etc. So you can't study, one individual can't necessarily study anything. And when you go really deep, it doesn't leave a lot of room for other things. So specialization is important. I'm not saying nobody should specialize, don't get me wrong, but something has happened with cognitive science, okay? Because really, ideally, cognitive science, by being about all mental phenomena, it's not just the purely cognitive mental phenomena. In the classical sense of cognition, if you go back to the Greeks, cognition is more about the thinking parts and the reasoning, decision-making to a certain extent. But then they parcel off, say, the will as being something else, emotion as being something else, motivation as being its own thing. And then there's the whole questions about physiology. Cognitive scientists are interested in the brain as a physiological mechanism that underpins cognition, but there's all kinds of things that other aspects of physiology that one might say, well, that's not really cognition, or you'd have to stretch it. In any event, these other things don't tend to be studied under the rubric of cognitive psychology. Now, personally, I'm not that interested in just one aspect, just the dry aspects of being an agent. So I'm trying to develop this more broadly. And point out that you go to a cognitive science conference, my experience has been that if emotion or motivation show up, for instance, in some of the tracks, it's about, they'll be talking about the interactions between cognition and emotion as if there's something different. But really, the mission of cognitive science, to which lip service is paid, is actually that we're interested in mental phenomena. So the distinction between cognitive and motivation shouldn't really bear out. One, you should be able to study motivation as cognitive science. And also we find that motivation itself is just a different side of a coin, or it's intertwined with cognition. And that's a position that was articulated in a book that you see on the right here, called The Cognitive Emotional Brain by Louis Pessoa. And the point he made is that there's no sharp divisions between these different faculties, if you will. The concept of faculty doesn't really apply. There's a blending or an intertwinement of these things. So it's not just about interactions, but it's about integration and so on. So on this slide, I point to a great book by Alan Newell called The Unified Theories of Cognition, in which it specs out multiple requirements that theories of mind should explain. And it's, he hits the nail on the head for so many of these requirements, and the ensemble is beautiful. And this idea that he proposes that we need to develop these cognitive he calls them cognitive architectures. So information processing architectures. And that's all great. But if the details, unfortunately, are that motivation and emotion, for instance, are essentially footnotes. They're mentioned, but they're not addressed in any serious way. And so then the question is, can you tack it on, or should you see it from the beginning? Well, from the integrative design-oriented approach, let's call it the IDO approach, you need to be thinking of it as soon as you're saying IDO. So, okay. So I've also pointed in this slide to a book by a 2-volume book by Maggie Bowden called Mind as Machine. Okay, it's a history of cognitive science. And what's interesting there is that there is treatment of motivation and emotion, and not just as interactions, but as being part and parcel of what the human mind does. She herself published a book called Purposive Explanations in Psychology. She's always recognized and that was in 1972 to 4 or 6, something like that. She's always recognized the primacy of motivation, purposiveness in being human. She, by the way, Maggie Bowden, is a historian of cognitive science, obviously, but she was writing books about the history of cognitive science from a very early time, and has written a huge number of books on AI per se. Anyways, we're actually, Aaron Sloman, myself, I think, and Ian Wright, our papers are actually cited in some of the emotion stuff. So we're, of this book. So we're quite happy about that aspect. Okay, this brings us to the IDO. What the concept of IDO. This is where I lay it out. When I gave this talk, somebody asked me, well, what do you mean by integrative? Well, it's on. This is the slide that explains it. Like a lot of terms, the definition goes beyond the actual what you'd expect just by the term. Okay, so it's more than just we're integrating stuff. But the key is it's integrative in the various senses here, and it's design oriented, meaning that we use the designer stance. You could be doing experiments, but you've got the designer stance in the back of your head. Okay, because an expression. There's a concept here that theory can't be true if it couldn't possibly be true. So sometimes you don't need to verify that the theory is true, because it couldn't possibly be true if you can't run it through, if it's not an output of the designer stance. So anyways, that's a core concept. But to go up to the second line there, you see that the focus actually becomes on autonomous agency. So it's not about behavior or faculties. That's an important point. I toyed with the idea of, well, should we call this a different science, really? Maybe we should replace IDEO science we should replace cognitive science by IDEO science. And I decided, no, that's not a good, let's not try to do that. It's an approach to studying something. It's true to the heart, core ideas of cognitive science from the past, the 1970s, trying to get back to that. And it shifts the focus over to, it's not even to behavior, like I say on the slide. It's that it's to the humans or other beings as autonomous agents. That requires an entire presentation. Actually, my thesis was on goal processing and autonomous agents. If you read the first few chapters of that, you'll get the idea. But other people have brought it up now, and autonomous systems are quite popular. So these are systems that are capable of producing top level goals and pursuing them in an environment that is competitive, not always friendly, often has dangers and various opportunities, and it's not a completely knowable environment. So the agent has to deal with limited knowledge. And once you add these things, you go well beyond, say, chess and a lot of simple environments into something that's more natural and more difficult to explain. So another core tenet is that the functions of interest are integrative, or are interwoven, that is, and they can be blended. So distinguishing something that's emotional versus it being cognitive, again, such as in pain, such as in valence perception, in so many aspects of what the brain is actually doing, is that value, as soon as there's a value, not proposition, but as soon as there's value being processed, you've got blending. Cognition and value processing are so often intertwined. Okay, and there's an integration of functions. So memory, decision making, assessment, lots of things are going on when we're taking an IDEO approach. When we're looking at the brain from an IDEO approach, or possible brains. We retain the interdisciplinarity in our approach, but then we say, look, we emphasize that it's also we need multidisciplinarity. Okay, so in order to address such difficult requirements, we need to work in teams. Okay, and the teams will have different specializations, including AI and traditional software developers, including in particular software architects. This goes back to Newell's book and the idea of architecture, of studying information processing architectures. I should point out, by the way, that I did a bit of research. The first person in AI to actually use the expression information processing architecture was actually Aaron Sloman, at least on record. You can find that in the 1970s. Maybe if I'm wrong, you can correct me on that. It's kind of relevant for here because this approach kind of has its roots in work that Aaron Sloman was doing. He was my PhD thesis advisor. Anyway, right. So it's got to be multidisciplinary, and you need software architects. If you look at any big software development project, a commercial one, there's always going to be a software architect. And yet, in psychology and AI, that's right now it's still rare that these architects are brought in. So I think they need to be brought in for big systems. Okay, so we're looking at well as theoretical integration. Now, I've done work in emotions. I'm very interested in traditional. If everything's blended, so what does it even mean to say it's emotions? But I'm interested in a phenomenon called mental perturbance and more emotional aspects of human functioning. And in that literature, you see there's many competing theories of emotions, and the authors or their proponents, the people in their different camps, they're kind of promoting their theory as being the right theory. When I look at that, I think, oh my goodness, looking at it from an IDEO perspective, I think, well, there's truth in that, there's usefulness in that. They're just like they're looking at different requirements. Nobody sees the full picture. They're looking at different requirements, and we can basically assemble from them. It's not that every theory is necessarily useful, but let's try to integrate and grab the strengths of the different theories and use whatever, basically. And in fact, this entire approach, this IDEO approach, basically says, I'm going to call anything IDEO cognitive science. I don't care if they call themselves social psychologists or economists or philosophers or whatever. If they're saying anything meaningful about how to build an autonomous system of interest to me, it's a human-like autonomous system, I'm going to pull it in. Hey, that's cognitive science. So if you look at my book that I'm going to talk about a little bit, my first book called Cognitive Productivity, I'm drawing from all kinds of things. And, it's just, I call it, hey, that's actually cognitive science. We can use that in cognitive science. We're going to integrate all kinds of stuff. Another aspect of this is that we have to think, there's a recognition here that we have to think in multi-scale terms. And on this slide, I mentioned, not to distract you too much, in smaller text font, Seth Grant, who's cited in my first book on this very topic, is that what's happening in terms of the information processing in human brains and similar brains is actually happening at multiple scales. Now, the connectionists, this is pretty funny because the connectionists in the 1980s and thereafter saying, our models are more neural-like because, or they're more brain-like, they're more not realistic because they are, because our units are actually neuron-like. Well, for one thing, their units look nothing like real neurons, okay? They, too, are doing useful simplifications at a certain level. It's not that there's something bad with that, but let's call a spade a spade. If you look at what's happening in the human mind, in the brain, and look at Seth Grant's work, you'll see that everybody knows that a neuron, can have thousands of synaptic junctures. Each one of those synaptic junctures, if you talk to Seth Grant, you'll see that it is itself extremely complicated machinery, way more complicated than the entire systems that most of the connectionist models were modeling. And that's just part of a neuron. And you can go lower than that. So now, of course, things get complicated. So we can't expect everybody to do that, but we need to work in our heads with a recognition that even at the neural level, there's multiple scales going on, and the connectionists need to have some humility too. And it's okay to work at a higher level because there are separations of concerns, and computer science has shown that you can have these you can work at the different levels and make meaningful systems exist and make meaningful functionality exist. If you go to Google, look at the TCP/IP stack page in Wikipedia, the page about that, or other telecommunication stacks, you'll see that there's these different levels of ontology, meaning being, and causation and rules. You can have specs at each of these different levels, and they can the specs often specify what happens in terms of communication from one level to another. Okay. And there's real causality happening here at each level. Well, that's interesting. If you look at software, you see there's often talk of virtual machines. What's a virtual machine? I'm not talking about virtual reality. Look at virtual machines, and you see, that's interesting. You have machines that kind of stacked on machines. There's an abstraction there. That there's causality happening. Well, it turns out, why am I talking about this? It's actually central to understanding who we are. We've got these virtual machines, and if consciousness is anything, or if we're to explain what feels like consciousness, we actually should be referring to virtual machines. We need to think, I was saying that using the IDEO approach, you need to be able to think like an AI person. Well, let's face it, you need to be able to think like a computer scientist. Not necessarily, in addition to just real, AI is part of computer science, if you will, but there's research in computer science on data structures, etc., that, say, for instance, connectionists might not think is very relevant because they don't work with data. They don't like working with data structures or admit that they're working with data structures. But in fact, data structures are quite relevant, and virtual machines are relevant. So if these connectionist networks are to do anything interesting, they better be able to act like virtual machines. You'd better be able to stack them and have causality happening. Anyway, so guess what? If you're reading a book on consciousness and it doesn't mention the concept of virtual machines, then there's probably something wrong. I would say, well, how far can you go without borrowing all that conceptual development in computer science? So anyway, not parenthetical. It's key to the IDEO approach that we're going to be talking about virtual machines. Now, when autonomous agents. So I'm talking about autonomous agents. That was my PhD thesis and a lot of my work after that, autonomous agents. One could get the impression that, these things aren't social. And in fact, at the beginning of my career, I was not that interested in the social. I figured, you got to be able to understand the individual before you can get to the social. And there's truth to that. You can't solve every problem at once. However, it turns out you can't really understand ourselves and sophisticated artificial agents without thinking in social terms, and in terms of Stephen Covey that put it so well, it's interdependence, right? So I pointed in brackets there to Michel Aubé's theory of emotions, but it's actually a theory of autonomous agency, really, where he talks about the crucial role of commitments. You can't understand what it is to be a human being ultimately without realizing, he claims, and I agree, that we mostly transact in commitments. Commitments underpin so much of what we do and so much of what we experience. So for him, emotions happens when something significant happens in relation to a commitment. It's not the full story, but it is an essential part of the story. I don't think you can understand emotions without realizing his stunning discovery, which is that emotions revolve around commitments. Okay, leave it at that. Google it. I've referenced it on my Cogsest website and in papers. So the whole social thing is part of this program. And as I alluded to earlier in the AI designer stand slide, the space of possible minds is something to be explored. Now that you could say, well, that's just implicit in the first bullet. So there's a bit of repetition there. But I wanted to draw it out because it is something that is so easily forgotten. The concept of space of possible minds is a great way to think about individual differences. People, if you look at the individual differences literature, you kind of get the impression that it's like a slider. You've got all these different dimensions, just dimensions. Somebody has higher, lower IQ. How you measure them on a big 5 traits might vary a little bit, but in fact, there are huge qualitatively different things happening, or people are qualitatively different from each other. They're mechanistically different. It's that, okay, in one person something's connected to another where it isn't in another. Look at the work of Annette Karmeloff-Smith on that if you're interested. She's I discuss her work in part 2 of the first cognitive productivity book, and you could take it from there. Now, the final business, which not business, but that's called the capture error, going back to Donald Norman and actually William James. The last bullet here is about applications of as theory testing. What does that mean? Well, if you're familiar with AI, you know that you run simulations partly to see whether what comes out at the end of the day is what you predicted, right? What you thought would happen. Does it work? Does it crash? Does it not do? Does it do or not do the things that you're interested in? Okay, so those are software applications of a theory, basically. So it's a process not only for solving problems in the real world, but for understanding and debugging theories and testing theories. Well, I maintain that process of attempting to apply a theory to the real world is also it's also a way of developing theory. So you can, like, for instance, we've got a theory. I've made a prediction based on a theory that cognitive shuffling should facilitate sleep onset, in a nutshell. Okay. Now, I went there originally because I just wanted to solve my own insomnia issues or insomnolence issues, but then even from the beginning, it was actually a theoretical thing. So I was trying to put myself to sleep using some ideas, and I thought, well, if these ideas are true, then I should be able to put myself asleep by using this technique or that technique. So attempting to modify the world in a helpful way with your theories through some intervention is a way of thinking about of testing and developing your theories. It's not just a test. It's also, you realize when you're trying to go from a vague idea to an outcome through some manipulation, that, I mean, if you're listening to yourself and being honest, you realize, oh my goodness, there's a question mark there. I don't know. There's something missing, My theory isn't really telling me how to get to the application. This attempt to modify the world can get you to improve your theory. By the way, this is relevant. I don't know that I've said this publicly before, but the Industrial Revolution, there's a belief that, science drove technology and the Industrial Revolution. But talking to historians of the Industrial Revolution, we find that no, actually business drove it. Business drove science. That the science was not developed enough they just needed to build things, whatever it is. And that actually, there's such an intimate interaction back and forth between science and application. So it goes back to the point I made at the beginning of the slide where the guy was saying, no, you can't get for cognitive science application. That's BS. Well, I disagree with the guy, but I would say that it's more complicated than that in each direction. It's not top down from science to application, but science can inform application, and application can inform science. So we go through these beautiful loops. Okay, and I put the word business there on the slide. I was running out of space, but business needs to be involved in IDEO research. Why? Because there's the applied side. They need this. And these problems are too complex and expensive to solve without the help of business. And multiple businesses will need to be involved. Okay, so we need to encourage businesses. I have a business called CogSci Apps and CogZest, and they're both informed by and part of my attempts to understand human mind and so on. So business is important, and there are other reasons for that. There's a little bullet at the end that says AGI. You know that little word there? That's for artificial general intelligence. That's to remind me to tell you that what we're talking about here fits very well into this field called artificial general intelligence that has its own journal. I was invited to publish there, and I'd like to publish the IDEO R&D manifesto. Okay, and I am looking for people to work with me on that because it's a manifesto. I'm not going to have a one-person manifesto or two-person either. My name is not Karl Marx, and what was his name? Hegel or something. Okay. New rules. If we follow the IDEO approach to R&D, to research and development on autonomous agents, then new rules will apply. One of the new rules or sets of rules applies to authors and editors and even the readers. It's that when you're reading a paper that is in psychologies or uses psychological terminology or jargon, you would expect those terms, we now expect those terms to be grounded explicitly by reference to a theory. So you're not allowed to use the word goal or motive or affect or emotion or mood or arousal or consciousness, as so often I have seen in papers. Okay, I've jumped into the sleep research. Into sleep research. I thought it was really fascinating, but I was distraught actually to see that, oh my God, the word arousal is thrown in there, and it actually has multiple meanings, and there's no theory to base it on. They're not saying where they grab the theory. They're very loath. It's interesting to read sleep research. It's like, why aren't they talking about emotion? Like, they will actually avoid the term. And I think in a sense that's fair. They're saying, I'm not going to use a term if I don't know what it means or if I can't ground it in some paper and there's no consensus in emotion, or I don't know why, but you'd think, if you're furious, you couldn't fall asleep. If you're scared witless, you can't fall asleep, right? So you think that research on insomnia should specifically be tied to theories of emotion if they use the word emotion. Well, there's two different things going on there. If they use the word emotion, I would say, you have to define it. Affect, arousal, etc. That's kind of a point. And not just define it. Let's raise the bar even higher. You need to define it in IDEO terms. So define it with reference to a theory that at least attempts to be IDEO. We can't set the bar super high because guess what? There's no theory that really meets the vision that I'm developing here. Okay, but what the way humans work is when they set themselves to do something in a certain way, they tend to get better at it. And they do this socially through competition, so and through collaboration, such that this can drive this very requirement by authors and editors and readers, which I think is a legitimate required. Why on earth should we allow anyone using psychological terms? And it's not just psychologists. I mean, I'm talking about, for instance, in hypertext research or wherever, any applied anything. If you're going to throw in a term in a scientific context, you should have a basis for it. I imagine in physics, I don't read a lot of quantum physics these days, but I imagine that when they use the words force, energy, mass, etc., they will either explicitly reference the theory that grounds the interpretation of the term, or they're maybe the culture. Maybe it's univocal in their discipline, so they don't have to define it because we all know what you mean. But that's not the case for any of the terms above. Okay, I could go on at length, but I won't more than this. Now, on this slide, I point to a nice paper by Madhut Krishna and a person whose name I've forgotten and the font is too small for me to read, Heinrich or something. So this paper, they've got a paper called A Problem in Theory. It's one of many papers that have come out in the last few years, hurrah, on the importance of doing theory in psychology and cognitive science. And they set forth multiple criteria for theory, including the need to develop theories that are, I don't know that they use the word integrative, but essentially they need to they need to be progressive, grounded in evolution, etc. So we can draw from that. Although my short bullet list didn't mention evolution, if you go to the manifesto draft on coggzest.com, you'll see that the evolutionary requirements are mentioned as well. So I wanted to pull that Madhut Krishna paper out because I thought it was a beautiful paper, on the right track, important thing, and very relevant to the IDEO approach. And on that web page, I've listed a number of papers that are relevant to the IDEO approach. Now, how are we going to do this? What's a good approach for integrative design-oriented R&D? Okay, there's lots of approaches. Now, one of the approaches that I've taken is from my earliest days, was in PhD days, was to study phenomenon, think about theoretically at least, a phenomenon that can only be understood in integrative terms. In my case, that was a mental perturbance. Now, what is mental perturbance? And why is this guy inventing new terms? What's his thing with neologisms? So here's the thing. Let's define it colloquially. Well, yes. So let's just say that mental perturbance is a mental state involving an insistent preoccupation. Okay, to first approximation, that's what it is. So you're preoccupied with normally effectively charged content. I said normally because you could have something like an earworm. Let's put that aside. Effectively charged mental content. Well, I used the word affect. What does that mean? Well, ultimately that grounds out at there's an evaluation. There's an effective evaluation. Some of our terms will just have to bottom out. Okay, although we can say more about them. And the preoccupation is what? Well, in a mental perturbance, you have this motivational content that's being generated asynchronously to our deliberative processes. So the brain is able to engage in deliberation, deciding whether, when, what to do, for instance. Essentially, a lot of your executive functions, if you will, okay, can process content, motivational content or effective content, okay? So your brain needs to be able to generate that. So we have these motive generators in our head, and they are already they need to be doing the evaluations, and the evaluations need to be able to drive somehow, at least indirectly drive, whether you will consider them. Okay, so at any given time, your brain might have like 1,000. Let's just say it's 1,000. You've got 1,000 different motivators: your level of hunger, your level of thirst, your desire to have sex, your desire to meet the partner that you're with, etc. They're not just, when they're dormant, what does that mean? Well, it probably means that your consciousness is not very preoccupied with them. That doesn't mean they're not active, right? The brain has a lot of stuff going on that's not verbally reported, say. So you've got this competition of motivators, and some of them gain attention. So there's probably an attentional function going on, and that attention is basically sensitive to the property of the motivational content. And we call it insistence. Insistence is the propensity of information to, let's say, in a simple way, is to penetrate the attention threshold, grab your attention. And once it gains your attention, then you can deliberate over it. And while you're deliberating about this, you might, at a higher level, meta level, you might say, well, this is not the right time to be thinking about my girlfriend. I should be working. Okay, I should be giving this presentation. So then you might decide you want to postpone that. Don't think about it. Okay, but if you're really, say, infatuated, then you will have difficulty postponing that. So So I'm unpacking a concept that seemed simple that ends up being quite complicated, and that can only be understood in relation to multiple different functions of the human mind that I've just very briefly sketched out. So it's inherently an integrative concept, because in order to even define this thing, you have to refer or imply different integrative concepts, and the whole integrative approach is necessary for this to understand this concept. So I proposed with colleagues Sylvia Hanieska and Monica Pudlo that mental perturbance, which, by the way, the concept originally, the basic concept comes from research papers by Ernst Lohmann and Monica Croucher from like 1981 or so. The basic concept existed in literature, and I made a move at the time because they were calling it emotion. So when I joined the project in 1990, I suggested to Aaron that, first of all, I loved the concept, and I was discussing it with psychology friends, and they were saying, no, that's not actually an emotion. Emotion means this. But then there's about, 20 different definitions of emotion that psychologists have. None of them is authoritative. And I said, look, that is a waste of time. I don't want to argue about what terms mean or what emotion should really mean. Emotion's just a bloody label. Let's get on with things and give our concept, which is new, a technical definition. And it happens to be an integrative definition. So I'm not saying my strategy is coining new terms. No, that's not what I'm saying. That's just a subroutine. The strategy is to focus on integrative concepts and don't allow shifting of these, where your term will get redefined in different ways. The neologism here was useful in that you don't get to say, no, that's not really emotion. Nobody's saying, hey, that's not really mental perturbance. Why? Because from the get-go, we defined it this way. This is what we're interested in. Now, of course, one might say this is an interesting thing, but it only applies to AI, and that human beings won't ever experience this kind of thing, or not for these reasons. That's a valid question. But it's a very different one from, no, that's not what emotion means. No, emotions are something else. Okay, I'm not denying emotions. I'm just saying that mental perturbance is a concept that can be studied and is very interesting. And I'm saying it may actually explain what people call, some of what people call emotion, some of what they call obsessions, rumination, and repetitive thought. Grief, for instance, would be a great example of that. If you've ever lost somebody close, you know that you lose control of your thinking. You know that you've got an insistent preoccupation, and you might be interested in this concept of mental perturbance that it tries to explain that kind of thing. And as a matter of fact, in the final section of my 1994 PhD thesis in cognitive science, which was on goal processing autonomous agents, there's a snapshot of it. It was actually the final section. I suggested we might be able to understand clinical obsessions as mental perturbance, and that provides a path for treatments. Okay? So, wow. This was supposed to be about hypertext, and I've talked about all of this. Well, I guess this is a long presentation, but it's what I wanted to do. So, because I'm setting the stage, because I was actually invited specifically by Klaus Astenbeck. He asked me, well, if you do something on cognitive science for hypertext, I'd like that. Well, I said, well, I've been proposing this IDEO approach, not just to hypertext, but also to insomnia and other things, and understanding the mind in general. So I offered to do what I'm doing here, which is to explain what this all means and why it's relevant. Now, I would like to get into applications, because in a separate area of research, related area of research, I've become interested in insomnia, as I mentioned earlier. And I've used this approach to develop with colleagues a theory of sleep onset and insomnolence. So insomnolence is simply the difficulty falling asleep. Oh, guess what? There was a missing concept. There was a missing word there. For what is it? What's a term for not being able to fall asleep? It's not insomnia, because if you look at insomnia, it's kind of a clinical term. You don't have insomnia if it's 3 o'clock in the afternoon. No, let's make it better. It's 11 a.m. You have had plenty of sleep, so you have no reason to be falling asleep. Your clock and sleep-wake time are telling you you shouldn't be falling asleep. That's not insomnia. That's insomnolence. Okay? And also, by you calling it insomnolence, we demedicalize this phenomena, which is what I've described. In any event, sleep research is very interesting. They've looked deeply at chronobiological factors, the clock and sleep-wake timer, to explain sleep timing, essentially. Apart from that, there's just sketchy ideas about different things that might affect your latency to sleep onset. And I wanted to understand it from a integrative design-oriented perspective. Came up with this theory that has look at all these 7 different things, processes that might, or sets of concepts here that might affect or be relevant to sleep onset and insomnia. So I've claimed in this theory that motivational perturbance is insomnolent. If you've got if you're in a great state of preoccupation with effectively charged mental content, it will be difficult to fall asleep, says this theory. And there's reasons why, okay? So we're not just throwing in an idea here. We're technically defining it. We say, look at mental perturbance. There's a mental perturbance will be insomnolent. So that means the human brain must have mechanisms that are sensitive to mental perturbance somehow. The sleep onset control system, although typically thought about as something quite modular, in humans, according to this theory, it's actually sensitive to a lot that's going on in the brain. I don't know about lower animals. I'm not going to pronounce myself about that. But with humans, actually, what research has found is that the reach of consciousness is great. Hockey players can do amazing things and become better just by imagining themselves in certain situations. Biofeedback can affect just about anything. So consciousness, if you look at the brain, prefrontal cortex is within 2 synaptic junctures of just about anything in the brain. So it's okay to have non-modular functions in the brain. Modularity is highly overrated. Okay, that's a different story, but it is elaborated in the Cognitive Productivity book, part 2. Another notion is that, the brain has these alarms systems in it. Now, Hans Selye, the famous inventor of the concept of psychological stress as a scientific concept, if you look at his initial papers, he talked about alarms. That idea was not really pursued in cognitive science at all until Keith Oatley had a footnote about it in his 1992 book on emotions, Best Laid Schemes. It might have been mentioned in an earlier paper of his, I can't recall. Aaron Sloman took it up, and lately Bernard Bars has actually, and colleagues in their LIDA, have a section on alarms. I would suggest alarms are really interesting, and it'll probably be a game changer recently. In any event, they're in our theory that alarms are, if your brain's generating an alarm, that's not going to be a good time to sleep. So if you basically with this paper, what I've tried to do using the IDEO, or this theory that is, using the IDEO approach, is reverse engineer the sleep onset control system. That's a big idea. That's a designer stance. That's big idea number 1. Big idea number 2 is, look, we're talking about all these things. I said mental perturbance was integrative. So therefore, this is an integrative theory. We've also said that, and perhaps we were the first to say this, that N1, which is the first stage of sleep, which is not really sleep, it's the transition between wake and sleep, is insomnolent. Moods, which we would need to define, what's the theory of moods? Well, I'm going to point to Thayer and Russell. Okay, and I'll take Thayer's book, his book Calm Energy. We're going to use that and say moods are essentially energy and tension. Okay, and then classical conditioning can also is also relevant to the SEOCS. It uses classical conditioning as well. Okay, so all these things, these factors are somehow integrated in ways that I haven't sufficiently specified. So it's not that we're at the end, it's more of a prolegomenon here, will affect sleep onset insomnia. But even from then, we were able to make a prediction that that the cognitive shuffle, which involves mentally, like imagine visually and kinesthetically, if you can, imagining various scenes or actions, and the various is important. So it's serial diverse imagining is actually the technical concept, could facilitate, under certain conditions, facilitate sleep onset. We developed an app for that called My Sleep Hut. We ran a few experiments on this. I won't actually comment on the experiments. Not the time to do that. But the main thing I want to say with respect to this is I want to loop back to Claude Lamontagne's PhD thesis. Now, he arrived at his predictions in a much more rigorous way than I did. Okay, but that's the direction which I'd like to go. Is say, okay, we've got this kind of a theory. Let's try to develop simple applications. Because at the end of the day, somebody using, whether it's a hypertext application or something like My Sleep Button, which is actually hypertext in a sense, is doesn't care about the theory. Just you might have to convince them that there's a reason this might work, but they'll give it a try often. If the professional sees fit, they'll have their client give it a try. And if the client tries it, we want it to have a potent result. That's the idea. Okay. So now I'd like to refer to the manifesto explicitly. There's a draft online. I just want to give you the URL here and mention the future publication and invite you, if you're interested in this approach, to look at this. Now, it's a summary of this already long presentation, is that the goal is to transcend dry and narrow, siloed cognitive science, affective sciences, and other ways of doing psychology. So you build on, you don't dump, you build on all the theory and empirical results with this approach. Okay, and we transition now to cognitive product, to the hypertext aspect. Okay, so now I'd like to illustrate ways in which IDEO R&D can inform and be informed by the development of hypertext software for cognitive productivity. And I've used these notions to develop a cognitive productivity framework, which I've published in 2 cognitive productivity books. Okay, so the idea here is to, the end goal from an applied perspective is to help people who value competence, and these are people I call affectant people, okay, use hypertext, so information in hypertext, to become more effective, essentially, so to avoid problems, to solve problems, to develop products, and develop themselves. So the framework is quite general, but it's by no means complete. So the structure of the first, Cognitive Productivity, which has much more theoretical content than the second book, I start by looking at the challenges and opportunities that knowledge workers face in using knowledge to go through these loops of creating outputs and becoming more effective. And I think that's a contribution in itself, to really have a detailed analysis of these things, the challenges and opportunities, because that's really going to drive the solutions, right? So that's what the third part of the book is about. Okay, how do we use existing software to become more productive? Because what I've found in the challenges and opportunities is that we've come a long way with software, but still software, in my opinion, has a long way to go. It still, in many respects, sucks. It seems to me that software is not designed from a perspective of cognitive scientists for the most part. There seems that the powers that be haven't necessarily thought this through. As a matter of fact, I got in touch with Steve Jobs after he announced the iPad. I sent him a note because I had written an article that basically predicted what should be in the iPad, at least from a so-called brain fitness or cognitive fitness perspective, and then assessed it. So I wrote him an email saying, it was really stunning what you've announced. And that was sincere. I thought, it surprised me, and I thought this has a lot of potential. But I also felt that if they continued in this direction, they would miss out on an opportunity. They needed some input really on the cognitive science side for cognitive productivity. So I offered to go down there or have a phone call or write a white paper, whatever. And he said, send me a white paper on it. And I did. And I did write a white paper quite quickly. And actually the cognitive productivity books can be read as an extension of the white paper that I wrote for Steve Jobs. So the software having these problems can be improved upon. And part 3 said, well, I can't, what I want to do personally as well is to develop my own software to address these problems, but knowledge workers can't wait for all this potential software to be developed, and I myself don't have the resources to do everything that needs to be done. So I wanted to just say, okay, here's how you can do it. That's the solutions part. So the book, though, it may be important to note that it strikes a balance between, it avoids, I should say, naive optimism, which is often, hey, we've got this technology, all's good, versus naive pessimisms. The Nicholas Carrs of the world said, oh, we're information overload, or just it's this rewiring our brain. Don't believe that. So anyway, but one thing to note is that users themselves don't necessarily know what they need. And I compare the situation with before the iPhone even showed up or iPad showed up. If you'd asked somebody just before the iPhone appeared, hey, what's wrong with your smartphone? How can we make it better? Nobody would have given you a spec for the iPhone. Well, I think it's the same thing for cognitive productivity. Say, well, software is not really great. How could it be better? So people don't necessarily know. So my cognitive productivity books are, at that point, I was like 12 years into this project of understanding this set of problems. Now it's been longer than that. It's been another 12 years since then. Now let me see, it was 8 years. But anyways, it was 8 years at that point, and I've been into this for over 20 years, let's just say. So I've got a pretty good idea, I think, of what we need. And when you do a project like this, one of the things you realize is that there's missing terms and there's missing concepts. So even to describe what knowledge work's about, you run into gaps because we're still using like 19th century, 15th century sometimes terms for describing working with information. So just to grab a random example, there's no term for delving any document. So you can read something, you can listen to something, but we need a term for processing information in depth, regardless of the form of the information, whether it's a screencast or a book or whatever. And then we need, the cognitive science concepts to kind of back that. Another concept is productive practice. So we're going to talk about productive practice. I'm going to mention potency and some other concepts very briefly today. Missing concepts. It's often the case, right, when you delve into a project, an area. So the cognitive productivity, the second cognitive productivity book is more applied, and it's divided into 3 sections. I'm proposing principles for self-governance. Part 1, principles of productive information processing. So the actual processing information, and mastering that information. So in more detail, you can see how I've fleshed out those principles. In this talk, I just want to briefly touch on a few of the principles that I've put in bold here, because it's just put a bit of meat on the bone so you can see where I'm going with this framework. Now, here's a challenge. How can we help knowledge workers assess information? Better assess information. So we have to understand what that's about. There's a loop that we all go through when we have potential information or information that we can potentially process. So when you first heard about this talk, or maybe somebody sent you yet another YouTube video that, hey, you should watch this, or PDF you might want to read for something that you're doing. For any given information resource, we have to make a judgment. And often it's very quick and it's automatic. Is what am I gonna process this information? When am I gonna deal with this information? If I'm going to, how deeply will I go into this, and for what purposes am I going to do this, and how am I going to process the information? What tools am I going to use, etc. So all of these decisions, which are often implicit or very fast, depend on your assessment of the information. Okay, and like I said, that's very automatic. But the thing that but it's super important. Like, that's kind of the gatekeeper, right? I mean, the information you take in, whether it's for learning or for production, that determines the quality of your learning or your production, right? To a large extent. So we know from literature on expertise and personal experience that a lot of the things that we do automatically, we can do better if we become explicit about them, if we think about them in certain ways, if we practice them, if we read about how to do them better, etc. So that's what I did with this assess analytically framework or principle. So I've turned to cognitive science, and so if we're going to assess stuff, we need a value framework, right? So there's some value frameworks in psychology, and I've pulled in a few for this principle. One of them comes from Ortoni, Clore, and Collins. They published a book in '88 called The Cognitive Structure of Emotions, which was very influential for cognitive approaches to emotions. Okay, and I should point out that whatever drives this, like this is an emotions framework, but ultimately this, we need a framework of value processing if we're going to understand autonomous agents, if we're going to build robotics that are autonomous, if we're going to understand how people process value, we need a theory of value processing, and that's at the core of agency. We're continuously monitoring for value, for looking out for opportunities and challenges, and we're making decisions that are value laden. And going back to Pessoa, that's kind of built in. It's not just, there's a separate value function there. It's built into it's intertwined with a lot of high order and low order cognition. So there I'm pointing to Ortoni, Clore, and Collins, and they claim that, we assess information in terms of three different high level categories: the praiseworthiness of something, okay, of an option, say, or behavior, okay, and we do that in relation to standards. So whether they're moral standards, professional standards, or whatever. We also assess information in terms of desirability, and that means some kind of a comparison with respect to our motives, our projects, our goals, etc. So we're going to need to flesh out those concepts in a bigger theory, which I've tried to do. And we also assess information in terms of its appeal. Do we like it or dislike it, right? And the thing about appeal, of course, is that it's misleading. It's often misleading. So there are people out there that are trying to suck us into reading their documents, watching their movie, watching their films, etc., so that they can, they want to hijack our minds for whatever purpose, and we need to be, therefore we actually need to downplay the attitude part. So, but we need to understand it. You can't downplay it. You can't protect yourself from being fooled if you don't know that this process is happening all the time and what you can do about it. So, having said that, this led me to develop a framework based on this, which involves, which I've called the Coupa framework. So, caliber, utility, and potency of information and appeal of information are things to assess. And as you can see, I've put the A side, the A aside, because appeal is actually different. It's the red herrings and the seductive appeal that you have to watch out for. You may have noticed that I've thrown in a term that I hadn't mentioned before, which is potency. What the heck is that about? That's actually more traditionally cognitive, but it also deals with affect. So potency of information. So I've kind of given that a technical definition. It hadn't been done before. It's basically the mind, informally, it's the mind-bending potential of information. So it's how much work and mental change, so it's not just purely cognitive, mental change is required for you to adapt to information, okay? For you to accommodate to it. If you know anything about Jean Piaget, he distinguished between assimilation, which is basically pigeonholing, and accommodation, which is more like mental development for in response to whatever challenges or development, but it also applies to taking in documents and understanding them. So if, for instance, you were to buy into this framework that I'm developing, it might change your caliber judgments yourself. So it's kind of meta, sorry. It can change a lot of things. Obviously, it gain factual information and understanding in other senses, but it might actually affect you as well on a more effective level, affecting like your standards. When you encounter paper, now you'll be saying, well, yeah, they've used this term, but they haven't really defined it. So your own assessments have been changed, right? And your own utility judgments might change. Your own motives might change. You might have a project. Oh yeah, I want to hire somebody. If you're a manager, you might say, you know what, we should have an IDEO cognitive scientist in a team or something like that. So you might it'll change you as well. So it's like the assessment leads to changes in how you will assess other things in the future, and it might affect what you like or dislike as well. Okay, but getting back to potency, so if you already, like, potency is relative to the person, if I were to present this information to somebody who's already familiar with my work, it's not going to be potent for him for the simple reason that they've made the mental changes, assuming they have, right? So it's an interaction thing. It's how much you already understand it, how much mileage you have to go, but how far can this particular information resource take you, if you will? How far can it change you mentally? So that, my friends, is potency. I think it's very interesting, and it's extremely difficult to it's an entire area of research that I think requires work. I don't know that it had been pitched in this way before, framed in this way before. So I mentioned that this talk here is a potential source of understanding this. Okay, so what do we have here? I wanted to point out at this point that, cognitive science is interdisciplinary, and one of the disciplines that's very relevant to this is philosophy. So philosophers have looked at ways of assessing information. So if you were to read this chapter of my book, you'd see that I make a lot of references to philosophers. Now, I'd like to say that this is to emphasize, as I said before, that this is kind of recursive. I think that we can be informed by philosophers, but philosophers can definitely learn from this. And I'd be disappointed if no philosopher who writes about argumentation and how to assess arguments and how to assess bunk versus useful information, which actually has to do with the caliber of the information, were to, if none of them would actually take notice of this, because this, I think, is great. And it's great. I mean, it's my work. I mean, I think has a lot of potential for them. And on the slide here, you see that I'm talking about beyond likes and beyond the crap test. So the crap test is an educational framing of how to assess information in terms of currency, reliability, accuracy, authority, purpose, point of view. So high school students are taught this stuff. So this is more for university level training and professionals, because we're going at it more systematically, more exhaustively, and deeply as well, and bringing in cognitive science. And ultimately, in terms of the applications that come out of this, they could be manifold, really. Like, what software? Here's a question for you: what software do you use to track your ratings of information, your assessment of information? Well, if you're like everybody else, there's no software that allows you to do that very systematically. There's some software that allows you to like or dislike stuff, Facebook kind of concepts. You can have 5-star rating systems, but that doesn't really cut it. So in my book, I've suggested ways of using Pinboard, which is a bookmarking tool, to handle some of this information, and how you can keep track of this kind of information in other software. I'm not suggesting, however, that every piece of information needs to be explicitly, analyzed in terms of these different criteria. Like a lot of skills, you end up compiling them and not needing to do things very explicitly. But we definitely need to be sensitive in whatever way, at least tacitly, to these different criteria and do a good job of it. It's not just a matter of assessing in terms of the criteria, but trying to do it properly. I'll point out software-wise, for instance, that when we're talking about utility, that has to do with how information relates to your projects. Well, you'd expect to be able to connect information resources to various projects, because that's where utility is derived. And we're still not there. We still haven't tackled that problem, but we're getting there. I'll be talking about a software called Hook that allows you to connect information to projects in project management software. So somehow, when we're dealing with information, we have to connect the information to projects. If you're using a tool like, I used to use Papers, now I'm on to new tools, but with Papers, I was able to organize information in terms of my projects. Right. Okay. There you go. Assessing analytically, I wanted to highlight that each criterion is potentially complex, and that it's an interesting ideal hypertext problem. So that's to sum it up. Okay, so now we'll move on to another principle, which is to practice productively. So I'd like to point out that there's a lot of research in cognitive science on the benefits of practicing. It turns out that that there's actually several different bodies of literature that don't always reference themselves on this. Okay, so we have in educational psychology, it's called test-enhanced learning. It turns out that students who self-test or administer tests for learning purposes actually do better. So I know that a lot of people, a lot of teachers may complain about testing and I think it's rote memory, etc. Well, if testing is done right, it's actually extremely potent. It's not just for developing rote memory. You can develop everything in Bloom's tax. Well, a lot of what Bloom's taxonomy of learning outcomes is supposed to deliver through testing. So it's undoubtedly extremely potent. There are test effects in memory. So if you look at basic cognitive psychology research, there's testing effects, and just recalling information does something. J.R. Anderson has expressed something that a hypothesis that I've kind of reformulated and called the heuristic relevant signaling hypothesis. And the idea there is that the brain needs a cue to determine what information to pay attention to, or to actually recall in the future, because you take a lot of information in during the day, but you will not be able to recall all that information. The brain can't enable you to recall everything. It has to make a decision implicitly every night when you're sleeping or during your naps. It's actually making decisions, I would say, about what's most relevant for you to be able to remember in the future. Okay, the cognitive aspect of it. And then it must build up indexes for that, and hippocampus and other brain structures are probably quite important for that. And a cue that it uses, so it's a heuristic, it's implicit in the system, is as the cortex and parts of the prefrontal cortex try to retrieve the information. So trying to retrieve information is a cue to your memory system that you better set up indexes, that it had better set up indexes to be able to recall the information. Now that's just one of the ways in which this works. There's lots of literature on it. And in the areas of expertise that I alluded to, in the research on expertise, that I alluded to earlier, it's very clear that in public performance disciplines, budding experts and experts practice. So the best musicians continue to practice. They'll do their scales, and they'll practice particular pieces, of course. Chess, this applies, of course, in all kinds of disciplines. And going back to test-enhanced learning, and a lot of students know this. It varies by disciplines, but in a lot of disciplines, the best students know that they better practice if they're going to be able to retain the information past the test. If the term is designed properly and the exams are designed properly by the teacher, they won't just be able to cram. They'll have to practice throughout the term. So they know this, and a lot of them will do this, and it'll boost to the extent that they're motivated. Sometimes people have more facility with information and they can just read. My mother's one of these people. She would never prepare for exams. She'd actually read the stuff over once and be able to retain it. So she's quite an amazing person. She got her some undergraduate degree, then a law degree that way, and it used to baffle me. But most people need to do practicing, and I think that her let's just say things would have stuck better probably for her, and her grades would have been even better if she had used this technique of practicing, and more to be better in the long run. Anyways, having said that, one interesting fact is that practice tends to drop out after students graduate because, well, societally we're not set up for that. They are busy people, and they think, well, there's no exam anymore, so why should I bother practicing? You need a lot of self-regulation to keep practicing. I think that we've got a cultural gap, and it's partly a software gap. So I was trying to convince Steve that, look, we need to build productive practice into the Mac OS and to the iPad's OS and iPhone OS, so that people, they're prompted to use this extremely powerful tool. And I'll talk about how Hook can help connect information there. So now to expand on what I've mentioned earlier, traditionally these forms of testing and test-enhanced learning target mostly factual information and skills, mostly the dry cognitive stuff. But I think it can be the tests can be designed, and this is a goal, and the reason I coined the term productive practice is I wanted to go up a level and say, no, not just about, it's not sufficient to target factual dry cognition. We need to go for understanding. Ultimately, we want people to be able to perceive the world with concepts that they're learning. Concepts is important. By the way, I forgot to mention when I was talking about potency, what determines potency is largely the conceptual richness of the information. So concepts are super important, right? That's what, not just what you retain, but what you want to think with in the future when you take in some information. Again, we also we often want to develop norms and goals and attitudes. As I was saying earlier, if you're learning some about a new standard, you want to, and you believe, hey, this is really important, it's high caliber, I want to live this, well, you have to change something's going to have to change in you that's not just factual, okay? These forms of value will change. Obviously, we want to apply information as well if it's relevant and useful. Well, if it's high caliber, useful, and useful, we want to be able to apply it in the future, right? So the 7th principle of my second book is actually about that. I think that's, the end goal is usually, well, I want to be able to apply this either in my thinking or in my problem solving, problem avoiding, etc. And that means transfer of learning. The idea of there is that if you, often we don't even learn the stuff at the base level. If you're reading so much information, you won't even have learned it. So the concept of transfer is irrelevant. But if you have learned it to a certain extent, the transfer aspect is being able to use the information, to recognize its utility, to detect that it's useful in particular situations, to connect the information in situations, and to elect to do this work. That those are actually concepts from David Perkins and Solomon and others. Okay, so that needs to happen. So how the heck do we get there? Well, it depends on the training, etc. But a good coach, if you look at what was his name, John Wooden, the basketball coach, famous coach. He was he proved to us that not all coaches are created equal, right? So in practicing productively, we need to be our own coaches and aim for transfer of learning. We also need software. We need basically, ideally, what you'd have is somebody like John Wooden, who's an expert in any discipline that you're trying to learn, and he's embedded in software, and he's going to coach you, and you'd be able to say, this is what I want to learn. I want to learn A, B, C, D, E, F. You can't learn everything. You have to choose, and he's going to tell you, well, there's a cost there. Can't do it all. The software will tell you that. Anyway, ultimately, as well, habits and propensities are things that we want to change. Without habits, you're not applying stuff. So it's a tall order, and obviously, to me, cognitive science is very relevant, and we need to think about how to use that cognitive science to develop solutions, which again are like Claude Lamontagne's experiment, like my sleep button. Ultimately, we need software that's very simple and fun. Okay, so I've mentioned the literature. Now I want to just point out that there are here as well missing concepts. There's flashcard software out there. I'd mention Anki. I'd mention relatively new software called RemNotes. Okay, but their flashcard software. I think the idea of flashcard is very useful as a starting point, but we need to move beyond it. If we're going to take this approach, and it's 2022, and we want to go deep and not be stuck with the physical ideas, even RemNotes, very nice, but it is still based on a flashcard concept. I think we need to think in terms of knowledge and mindware, software in your mind, instillers. We need to think in terms of not of questions and answers, but challenges, and so on. And one thing that we need is we need ubiquitous linking. We need linking software. We need to be able to link. Here's what we need to be able to link. You're reading a document. Let's say that you were to do that. You recognize that, well, if I'm going to learn this stuff in this document, if I want to learn these 3 things in this document, or even just one thing, I need to be able to connect that to a productive practice instiller containing challenges. Okay, so in the old terms, flashcards, right? And because I need to cross-reference stuff because I'm going to forget when I'm studying. I'm going to need to go back to the source, right? So we need that's just one use case for what I'm going to talk about next, which is software to connect anything to anything. But still, to go back to the productive practice side purely, is that there needs to be a cultural change. I think we need a cultural change, and I would have thought that big software vendors can affect that change. But after writing to Steve Jobs, I realized, oh my goodness, I think, for a lot of this stuff, we can do it ourselves, particularly the next part, which we ended up doing. I thought at first the next part only Apple could do it, but then I realized, oh my goodness, there's hooks in software, no pun intended, in macOS that enables you to do what we're going to talk about next. So there's another principle in my book that I call surfing strategically. And the backdrop there is that a lot of the information processing that we do is quite superficial. It's like, if you think of searching and retrieving and even skimming documents, it's not that when we're doing that, we're not, there's a distinction between surfing and delving, going deeply into a document, trying to master it. There's these other things are more superficial, but that's okay. Superficial doesn't mean not important. There's a lot of ancillary functions in the brain, like sleep, for instance, that need to be done, even if they may appear at certain levels as being superficial. And I believe that these so-called superficial processes need to be understood and can be optimized from an IDEO perspective. So I'm going to talk about a couple of these. I'm going to talk about the learning side first, and then I'll talk about production. They both involve navigating between information. So if you are, say, reading a document that's challenging and you really want to learn about it, odds are you're going to have to take notes. You might have to create productive practice instillers. You might want to draw a diagram. So we've already talked about 3 different kinds of information there. You might, if you're working in a team, you might have an email from somebody about that document that elucidates, maybe you've even written to the author or whatever, that elucidates something about the document. So you need to be able to take your notes in whatever software you love to use. I love Skim for reading PDFs. I don't write out a lot of notes in Skim because PDF editors are not good for that. Most browsers don't even have note-taking functionality yet, which floors me. We were working on that in 2002. Anyway, but it's okay because I've decided that, or I realized that what we need actually is just to be able to connect the source material to our notes and ancillary or other information about it. Okay. And that's important because if you're not able to rapidly navigate between a PDF and your notes about it, you probably won't take notes. Why? What's the point the answer is, what's the point of taking notes about this important PDF in some file somewhere if I can't rapidly, and by rapidly I mean 2 seconds. So in my books, my cognitive productivity books, I talk about the 2-second rule. There's information retrieval needs to be done in 2 seconds. But whether it's from your head, for certain stuff, you just need to be able to get it in 2 seconds. Stuff you master, but also information retrieval of your notes. You have to be able to do that in 2 seconds. Otherwise, you're not going to do it. And as a result, people are taking less notes, or they're not taking a sufficient number of notes compared to what they need to, even compared to, I'd say when people are reading on paper, because it was so easy to write in line. Whatever the specific comparisons are, the fact is we're reading so much information that you won't be writing it in a separate program if you can't rapidly navigate between them. But there's no software for that yet, and that's why we invented Hook. And that's the what I call the meta access problem. Another example is on the production side, and I've illustrated that here. But before I illustrate that, I want to go to the research actually, and note that there is research that's pertinent to this on long-term working memory, consciousness, etc. Experts, they are able to rapidly retrieve information very quickly. Your chess players, in their domain that is. So a chess player can look at a whole bunch of different chess boards, configurations, like 6 of them maybe, and for each one of them, he'll turn around and he'll be able to draw them out or describe them. He or she knows exactly where all the different pieces are on each board. That is called either template memory or long-term working memory, depending on your theory. Well, I'm not suggesting that we need to be able to do that stuff ourselves, but the fact is that for a lot of mental work, because information working memory is of limited capacity and it decays rapidly, we have to be able to rapidly access information as we're doing deep work. Otherwise, things just don't work. So there's a science behind that, is what I'm trying to get at. And I think hypertext research can inform that science more than it has. And it's partly because we didn't have the tools. Now we've developed Hook, which is one of the tools for this. So so I just wanted to give the example of when you're writing a document. So where's your draft? In this kind of bluish little color here, there's a name for that. I'm slightly colorblind. You will find a draft. So suppose that you're writing a document. You'll have a draft. You may very well, if it's a long document, have an outline. If you're an outlining type of person, you might have what I call elements, which are anything from references that you want to use to the thesis, description of what's your thesis, what's the argument, key ideas you want to describe. I personally often put them in a document, which I call elements documents. You might have them all in your head, but a lot of us will write these down. You might have various notes about that are, maybe, and by the way, these may be stored in different apps. I'm going through this to show you the challenge that we are all facing here. And if you're writing a paper, well, you probably have a whole bunch of PDFs that you want to reference. There may be web pages, and so that's a different kind of app. Mind maps, if you're that kind of person who likes to write a mind map, or diagrams, different kind of software for that. You might have other files, like it might be a spreadsheet. You might need to crunch some numbers. You might have to look at some data. You might have emails from your editor, your co-authors, reviewers, etc. And if it's a project, you better have a to-do list, and that's going to be in its own software. And maybe in it, so information is in all these different silos, and that's okay as long as the silos can be connected together. So we developed Hook, realizing that this this so-called superficial aspect of information processing needs a solution, and Hook essentially allows you to connect information in any compatible app. Okay, so we don't want to force you to use always the same software, like whatever that software might be. There's bucket software, and I'm not against bucket software where you throw a bunch of stuff in it, but that's not going to solve your problem, because you're still going to need to sometimes go out of that. And a lot of people like to use best of breed apps. I've developed my own, not my own, but I was on a project where it's a multi-million-dollar project, and we developed a great bucket kind of app called GStudy, and we did NStudy. We built a note-taking tool, a browser tool, a concept mapping tool, even a productive a flashcard tool in there at one point, as I recall, and all these different things. But how can you, on a limited budget, and even with a big budget, how can you make a best-of-breed component? So let's let everyone use their favorite software, high-powered software. And there's a lot of great note-taking apps. So we're not going to, people need choices. And the same thing for all the PDF readers, etc. So what that calls for then is just software to bridge information in the best apps to each other, and let users often create those links, and sometimes we'll create them automatically. And that is our software. It's called Hook. This is not meant to be an advertisement for Hook. It's a it's showing that from a cognitive science framework, when you analyze these problems, you can come up with solutions that are relatively original. There have been other attempts at providing link services and software, but you have to go pretty far back and look at very simple software before you can get something like, that what we've done is, I think, relatively unique at this point. Anyways, let's just put it that way. So this is a illustration of Hook, and anyways. But the principle, like I was saying, is broader than Hook, and basically people need software it entails that people need software that has linking capabilities, and a number of developers and professors in cognitive science related disciplines, influencers. In total, we were 24 of us. Originated the Manifesto for Ubiquitous Linking last December. So December 2021, we published that. And since then, many people have signed on. If you're into hypertext, if you see the value of this, you're very welcome and encouraged to sign this manifesto and share it with everyone in your network. So we've proposed that, we've stated, essentially, we've claimed that software nowadays, if it's user-facing software dealing with information that people might use for learning or problem solving or creating, the users need to be able to get links to information resources that this software deals with, whether it's a note-taking app or it's an email app or whatever. We think that the ability to copy a link is just as important as copy itself. If you've done any programming, you know that, well, referencing is probably more important than copying an entire structure. You reference much more often. So we want links, copy link as a first class command, not hidden in this place or that place in the user interface where you have to control click and I don't know where it is. Users need this to be a first class function in the user interface. And also we need an application programming interface, an API, so that people can build their own automation tools, so that developers can build apps like Hook that connects information, or special purpose apps even for connecting information. So we highly encourage software developers to build this facility in. But more importantly, we're encouraging end users to be selective about the software that they purchase and have them, if they see the value of links, which it's a movement now, by the way. Links are back in, Hypertext is back in, so that's nice. And we've been doing this on our team since 2003 or so, and it's nice to see that the world is catching on, but it's still relatively niche. We'd like to see this kind of take off globally. So vote with your dollars and choose applications that support your cognitive productivity, including ubiquitous linking, and it'll be better for your teammates if you have children or students as well. It'll be better for them if they can link information more easily, so that they can do better work and remain in flow and stay focused. So that's the manifesto for ubiquitous linking. It's actually modeled on the Agile manifesto in terms of its general structure. Obviously, the content's very different. The Agile manifesto changed the world, and we think and we hope, at least we hope and we think that this manifesto can have an even bigger effect in terms of being able to affect more people, because the Agile manifesto was for developers and project stakeholders, etc. It wasn't so much for, the general public doesn't need to know about the Agile manifesto, but anybody who's a knowledge worker needs to know about the manifesto for ubiquitous linking, because lack of this software is slowing them down. Okay, so here's a slide that outlines what I've already alluded to, is that there is pertinent research on this, on from cognitive science, on that backs the need for this and that help us understand what's going on. But we actually need more. We need more research on this from an IDEO perspective, and that means autonomous agency oriented. And also we need the hypertext research to feed back in. And I've just put in a few things there, extra areas of research, like cognitive and brain aging, for instance, is important, because as you age, free recall becomes more difficult, but cued recall actually is quite robust. So it would serve you to have ubiquitous linking software capabilities, as you age, because then you'd be able to rely on these scaffolds and do great work. People are doing greater work later into their lives now. A lot of the best prizes are being won later and later now, actually. Okay, so there's your distinction between cued memory and free recall. But I think we also need research in these other areas on IDEO. So on ubiquitous linking from an IDEO perspective. Now, I would, if I had more time, I could give another talk on these hypertext applications of these getting tired apparently, these areas of software that need IDEO hypertext capabilities and research. So one of them is psychotherapy. Actually, in the last or penultimate chapter of my first cognitive productivity book, I argue that acceptance and commitment therapy, which is can enhance or be an alternative to cognitive therapy, is very interesting and promising, but it hasn't been looked at from an IDEO perspective. It's actually quite behavioral. So we need that. And psychotherapy needs hypertext tools like this, for instance, on the productive practice side, because if you're, I give you a book, a self-help book, it may be a great book like Stephen Covey's self-help book. People have used it and learned it, but There's no scaffolds now. I mean, they had to do without scaffolds. It would be much easier to learn from these self-help books and psychotherapy books. And a good therapist, by the way, should be giving not just homework, but pointing people specifically to a great book that pertains to their particular problems. I'm a strong believer in that. But it's not enough to have a book. You actually need software to help you learn what's in the book and apply it in your own life. So we need research on that, self-regulated learning of anything. And then one of my pet areas that I've been working on in the background is learning from stories. We process a lot of information. And that's one of the challenges on the factual side is we're taking in all this information, so much information that we're not retaining or using and much proportionally because we're just taking in so much. So we need to slow down and process at least some, like a fraction. The stuff that's high in caliber, utility, and potency, that is where we need to direct our effort. And a bit of focused effort can go a long way. Now, the same kind of problem arises with stories. We've evolved not just to take in stories for enjoyment, but to actually learn from the stories. I strongly believe that and so do many other people, like a guy called Boyd, a professor called Boyd, that we are, we've evolved for, our appetite for learning comes from the fact that learning has many adaptive functions, but our appetite for stories comes from the fact that it has adaptive functions, but the information age has kind of blown that out of the sky because we're just going from one Netflix to an ebook to a Kindle book and whatever, and songs galore. It's on tap, Apple Music or Spotify or whatever, and we're not learning from the stuff. Now, if people tell me, Luke, this sounds pretty boring, I just want to chill when I'm reading a book or watching a film, and I think that's fine. But I would argue that if software were designed to enable you to remember and utilize information from the films that you're taking in, if it were fun, and I think there are such things as serious games, fun games. Serious games could be made fun. If it would be unlike Trivial Pursuit. Like some people might remember Trivial Pursuit, an oldish game now. People like that. They answer questions. Well, they learn nothing from those questions because Trivial Pursuit was not designed for learning. It was just designed for fun. But you could take that fun aspect and combine it with learning capabilities. Now, it's very clear that at least a lot of us have, really thrive on learning. So if you can build that sweetness pill in there and deliver competence and fun together, that could be very potentially interesting. So I'm open to receiving phone calls from Netflix and Amazon and anybody in this field to help them understand that and get there. This has been a long talk. As you can see, I'm getting a little bit tired, and I don't intend to edit this very much, if at all. So I've written my coda here, and there's a summary that you can pause and read. And what I will do is mention that there's a short version of this talk. If you wanted to go through this and get a summary that I gave, it's going to be online. The Hypertext people will, the Human 22 Hypertext workshop organizers will publish a short version of this. But I wanted to get more of the ideas out in this form, which apparently I have. So thank you very much for listening. I'm, as you will recall, Luc Baudouin, and I really enjoy this stuff. Hope you do too. Cheers.